Okay, so got a mortgage of 200,000, 25 years, monthly basis for the payment. So the only thing they give us interest is interest to start off. And what you could do is you could find out how much you can make a formula for the amount of interest you're supposed to make on the first payment. If you still owe $200,000, here, well, the interest is going to be the starting amount times the, actually, I don't think they use this formula at all, but the big idea is the interest is the principal times the rate divided by the number of compounding periods. Okay, that's the interest for one payment. So the interest for this first payment they said was $716.67. The principal was $200,000. The rate is something we don't know, but we do know the time in months is 12. Okay, so this is an equation we can solve for R, and that will give us our interest rate that we need to use this formula up here to figure out the present value of an annuity. Okay, so let's see. Let's just do 200,000 divided by 12. 666.66 repeating. And then we got to divide that from both sides. So 716.67 divided by that fraction gives us an interest rate of about 0.043 or 4.3%. So now that we have that, we have enough information to fill out this formula. Okay, so we want to know D. We want to know how much the payments are each month. Okay, so we don't know that. We know the interest rate was, oh shoot, I think it was 0.043. And we said the number of compounding periods is monthly, so that's 12. Okay, and then the formula up here at the exponent is negative t times n. Okay, and then you divide by 0.043 over 12. So right now we owe $200,000. Can't fit that in there. Okay, if we were to pay it all off today, $200,000. That's what goes in here for P sub 0. So when you're trying to get D by itself, let me see how fast I can. Just be really careful with the order of operations here. Do the inside of a parentheses first. That means division comes before addition. Then you got to do an exponent, so I'm going to copy that to my clipboard so I don't lose it. It was a 25-year loan. Oops, I should have plugged that in here. 25 in for T, 12 in for N. So 25 times 12 gives us 300. So this parentheses gets raised. To the negative 300th power. Then we take that number and subtract it from 1. Okay, so we got 200,000, the amount that it would cost if we paid it off today, equals D times 0.6580. Let's keep going. 458 all over 0.043 divided by 12. That's 0.00358. You probably know how to take the algebra from here, but 0.65804558 divided by that bottom number. And then to get D by itself, this number is multiplying to D, so you want to divide both sides by that 183. So for D, the monthly payments, I got $1,089. And 8 cents. Okay, let's see. We want to calculate B sub 1, the balance on the loan. So we know the total payment is $1,089.08. That's D. The amount that has to go to interest is $716.67. So subtract those two. Whatever's left over after you pay your interest is supposed to go towards the debt payment, unless there's other taxes and insurance. So only $372.41 goes to paying off the debt. So our balance, $200,000, subtracted by that payment, we owe $199,628 when we round to the nearest dollar. Okay, so just to recap what I did here at the end, this is the formula that we used. Give myself some whiteboard space here. There we go. We had a monthly payment of $1,089.08. That's our payment. If you subtract the interest, which was $716.67, that's the amount that gets to go to paying down your debt. So only $372.41 goes towards that debt. So we had $200,000 that we owed. We're taking off $372.41. We owe $199,627.59. But when you round, that's they say to the nearest dollar, $199,628.